Hello. Hello. Perfect. The voice is good. Uh, AWS, there's nothing here. Let me start. Day 7, that is to lay a foundation, growth, and concepts. In fact, we are doing this. I will go to so this is good. Let's quickly go here. We'll enroll. We're gonna start soon. Let me check if somebody joined. I'm already late too much today. I don't want to let it beyond this one because it's 12:30, 1:32, 3:30. 3 hours, right? So 12:30, 1:30, 2:30, 3:30, 1, 2, 3. Yeah. So in progression, resume. So we will have revision of this entire start in first two sessions, and the third session we are gonna focus on the assessment. And today we're gonna complete this first section. And tomorrow, before I join in, I will make sure that have I have completed the subscription, so it will be easy for us to do the things. Right? Mm, perfect. So let's get started with the Pomodoro, and we will start very slowly. Don't worry about this one. But before that, I will check everything is fine. This is looking fine. The voice I check. Two things I usually check: the voice and this one. So we are good. So and started. So in this first session of the total three session, what we gonna cover is introduction and data discovery, and the later two we gonna cover the AWS this one, and the last one we gonna cover this one, and then assessment, and we will finish our today's session. Plus, we're gonna complete this as of today, and we will be voila. So let's just start with the introduction. Okay. If you look at the introduction, what is going to talk about what are the key functions of data engineer? Key function, what are the key functions? They are responsible for building managed data infrastructure and ingest data from various sources, prepare the ingestion data for analysis, cataloging of the data, curated data set, uh, automate regular data workflow, and ensure data quality, security compliance. So we are responsible for these six steps that we need to talk about as we progress. Okay. So, and then this one, and we are pretty good. So we will talk about them one by one. manage, then ingest, then prepare data the ingestion. So ingest data from the source, prepare the ingested data for analytics, then cataloging, then automate regular data workflow and pipeline, and ultimately data security. And this one. Interesting, interesting, interesting. Okay. So before I move on this one, there are few things that we have to cover, and this will also become a part of my highlight. Okay, so this is gonna be highlight number one. What, who are data engineers? Okay, we need to answer this first thing to understand who are data engineer. Then we can go one by one. What are their key responsibility and furthermore. So question is, who are data engineers? Data engineers are the person who are responsible to convert raw data into something meaningful. So there is a raw data, it will convert, or he is responsible to convert or transform into meaningful data. Meaningful data. If we have to take an example, how about we take an example of mm, for data engineer, what should we take an example? Um, oh, 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 oh. Like we can take an example of whom? A person who is responsible to transform. Yeah. So, so let's take some examples. So first of all, like who are data engineers? So we are very clear that data engineer are the people who are responsible to convert or transform raw information or data into something meaningful and useful to construct something else. Let's take an example. Do you know the in the world there are a lot of tires, like the car tires or the bike tires that are being wasted every single day. There are companies who actually bring them in their storage or warehouse. Okay, warehouse. There inside this one, they burn them into liquid or some other kind of form, and then they use it by shading and doing other process. They convert them into very fine material like powder structure like this, and then they make them convert or transform them into bricks or some kind of warehouse, your shoes or some other like household products. Okay, and these items they then sell to the end consumer. They sell it. So look in the entire flow. What is happening here? They have a raw product that they bring into their storage. Then, based on the tires condition and the other things, they grind them. Then they boil it or something. They make it liquid. They make it fine powder something, and then they slowly convert into like bricks for construction, or they can create shoes, or they can create different other materials or items or finished product that they sell to the customer outside. Data engineers are the same people. What they do, they go to multiple places, bring the data into a central repository. Once data is available at this point, they are responsible to transform, like how they are transforming into something more meaningful and something more useful. How can be it be useful? These data can be directly shown to some CEO of a company through visual dashboards. Okay, these data can be used by data scientists to train their ML models, and then this ML model is further used by CEO and CTOs to predict. And this data is again can be shown directly to retailer end user to see their inventory or other things. Look at this one. The data that came from multiple sources, they just processed the data and made it something that is far more useful to different category of people. So this transformation from this side to this side, data engineer are responsible, and the entire process of converting raw data into something meaningful and useful by the end user is called data engineering. Perfect. We got it right. Now we understood. when we have a data here that's like something in raw product, right? Like raw format, and we convert into something more useful building block, and that can be used by other people, right? So in this entire journey of raw data into something much more useful, this is called data engineering, right? But what are the key steps or the key functionality that we need to perform in order to complete this task of or this journey? So there are multiple things that we can do it as part of data engineer. The core responsibility that lies for us is first data ingestion. I will tell you one by one. Okay, so these are the key responsibilities of data engineers. So what are the key responsibility of data engineers, or what are the key steps in data engineering? First one is data ingestion. So it's called data ingestion. Second one is data storage. Third one is data cataloging. Fourth one is your data processing. And fifth one is data delivery. And the sixth one is that we need to govern, we need to follow throughout this process, like from here to here to here to here. This is called data security and governance. Okay. So so these are very critical steps that we need to follow as part of data engineering, or as a data engineer, these are the steps that you need to follow. There are many other sub steps are there, but these are the major steps or the overview of the entire data workflow. It goes to data ingestion, data storage, then data cataloging, then data processing and data delivery, and all this being governed by data security and data governance policies, right? So these are the key responsibility or the key functionality as a data engineer you need to perform, right? So before we move, let's check out what else there is. Data building done. Cataloging done, automaton workflow. This is nothing. There's a part of this one, and this is a done. Okay, so let me tell you one by one what they are so that we are very clear on the things. Though the flow is data ingestion, data storage, but when we start working, so logically, the first thing that we do is data storage. So, what is data storage? So, for data engineers, they are responsible to design, develop, and maintain data storage for our incoming data or source data. Okay. If I have to explain you in a very simple terms, data storage is a place where you bring the data from multiple sources so that the data can become centralized and easily accessible by the different teams or different developers. Okay. And you're gonna ask me why it is important to make the data available, centralized. It is available for everyone, or make it centralized available, right? Reason is very simple. Suppose your data right now is available into five different places. This is place one. This is place two. This is place three. Let's say three. And what happened? You don't want to bring the data into this storage. You simply want to go and process it and get the data for your final dashboard or for final this kind of dashboard, right? Simply here. But the thing is, like, you realize that data that is available here is not a complete data. It has a complementary data that is stored somewhere else. So that means you need to go bring the data, then you need to bring the data from here, then you need to process, and then you need to send it. But but there's a lot of time when you want to see the previous data. The problem with this approach is two major problems. First one is, if you bring the data from here, and then you process and make it available here. Now the data that is visible is something that you process, suppose 1 a.m. in the morning. Okay. And after 3 or 4 hours, this data get refreshed. This data also get refreshed. Now, if you want to trace back, you cannot do that because either the data has been modified or new data is inserted. So the process that or the computation you have done might get impacted. So you can never trace it back. So the traceability have a issue if you directly try to read the data from the source and then process it. Second major thing is, so when you run your query, there's a huge chances at times that you need more resources. And the owner of this particular platform might not be happy to give you this power. Reason is very simple. Today, if you can do this, there will be thousands of other employees who want to use this data for their corresponding sources. So they also gonna request every time. So do you think he is able to handle all this requests for all these people when this data is specific to their department, that is called data silo? So answer is no. For this reason, we need to make sure that we cannot utilize their platform for our usage. So we need to bring this data from here to here in our centralized repository or a storage where all the data is available that we need for processing. With this, we don't with this what's going to happen at given point of time, we have a snapshot of the data that we bought and we process it to make it available for our CEO to see. And this is the reason we go for the data storage. Perfect. I think you might have some doubt. If not, that's okay. We will go. So this is the story of data storage. Now, what kind of a data storage? The problem with this approach is right now that the problem with data storage. What is the problem with the data storage? The biggest problem with the data storage is the data itself. Now, just imagine what happened as a developer when you work in IT or other places. You might be asked to bring the text data from one source, then the Excel data from another source, then your database, this data that is stored in a database from another system. So ultimately, what is happening? You have multiple type of data, be it MP3, MP4, Excel, CSV, or your Parquet ORC, so many kind of this one. And as of now, we don't know any storage who have the ability to store any kind of a data, right? Because we need a central repository where we can keep any kind of a data so that it is universally available for my team, for my developer at a given point of time. And from there, they can simply store that in a particular or some data storage which is more complementary or which is more efficient to store those data. But before that, I want to keep them in a place where they can simply drop and available for everyone. And that's where the concept of data lake came in. Data lake is a storage or centralized storage where you can drop any format of data. It's like file system, simply drop it. Any kind of file. You don't have to worry. And from here, you can take your data to corresponding softwares or data storage, those who complement particular type of data. Best example is if you have CSV, Excel, or you have like a relational database like tabular data, you can simply store this data in your SQL database or relational database management system or a database. Okay. If you have semi-structured data, for example, JSON and other thing, so you can simply use the NoSQL database. Okay. And that's how the things started to make shape. So data lake is nothing but a storage or centralized storage where any kind of a data can be stored, be it structured, unstructured, or semi-structured. So now with this thing, what happened, like this become a universal storage for us where all the data is available. So in case something goes wrong, we can simply go here and check our data, whether the data itself have a issue or we as a developer made the issue during our development or data processing. Perfect. So we are very clear with the data storage. Second thing is now data ingestion. Perfect. So what is data ingestion? So data ingestion is a process of bringing data from source into our storage. This is called data ingestion, and we already discussed why it is important, because with this approach we have to measure benefit. First one is the data is available in our system, universally available, so all our employees can access it at a given point of time. Second, based on this data we can simply use different tools to store them and process them more effectively, because this data is available in our system, right? So data ingestion, we are very clear, is nothing but the process of bringing data from multiple source to our data storage. Data storage, we are already clear that this is a place or software or the system that enable us to store the data. And data lake is very prominent because it enables you to centralize your data by making you store any format of data, be it structured, unstructured, or semi-structured. Let's go with the next term, that is your data cataloging. Okay. So if I have to explain all this thing with an example, let's take an example of you as an interviewer. Okay. Suppose today you act as an interviewer, right? I will give you an example how data storage and all this work. Okay. And you need to take 100 interviews in 100 days. That's your challenge, right? 100 interviews, 100 days. We clear? That's our primitive goal. Now let me ask you, if he has 100 interview, 100 days, 100 interviews, right? Do you think he can simply go to the place of the person he want to take interview, set up the environment there, take the interview and get it done, and then move to the other person, then another? Do you think at given point of time, these people allow him or you come to their house or office, mess it around by setting up different equipments for the interview and let you do the interview? Maybe 5 or 10 will allow, but remaining 95 won't allow this. Right? Exactly. Exactly. So instead of this, what he decided that I know what I have to do is to create a platform where I have all the equipment, be it my camera, be it my speaker, be it my recorder, be it my cameraman, be it my director, be it the plants, table, chair, everything, right? He will create a platform where everything is available. All he have to do is to ask this interviewer to come on day one, then ask the other guy to come at day two, and this one he will record it, simply store the data in the computer, then simply process the data and make it available for the user consumption on a platform like YouTube and other places. Right? So this is the basic flow. Now let's start curating it same way that our data engineer does. The person he is calling for the interview, sometime it can be one, sometime it can be two, right? So these are nothing but data sources from where we need to bring the data. If you look from this person perspective, what he is doing, he is talking to the guys one or two by talking, and every talk is captured in a camera, right, in a memory, which is later stored in a computer and then process it and made it something much more efficient, much more impactful, and then it upload that in the YouTube channel or GitHub or your Instagram, everything. And then the end user, the people or audience can watch it to entertain themselves or to learn from it. What exactly is happening here? He took the raw data. When I say raw data, is that raw? Then he stored it in a computer and start editing. So he removed the filter condition. He removed all the things that he don't feel like gonna contribute towards the overall picture, right? He edit here everything, and then he released this data into the YouTube channel where people consume it. So the raw data consists of 4 hour of talk that comprises of anything and everything, but this one consists of 1 hour of power talk. So you reduce those 4 hours to 1 hour. This is raw data, and now this is a process data which is highly valuable because it provides a lot of values, right? So what data engineer does, they does the same thing. They bring the data entirely into the system here, then they process it and get the output that is much more impactful, much more meaningful in terms of taking business decision in order or to utilize into their machine learning algorithms to understand more about the pattern and other things, right? So what he does, he told him that I can come to your places every time and set up the things, and at times it may be possible that my equipment while traveling might get break, or the lighting may not fit well, or your house won't be spacious enough to accommodate it. So ultimately what is happening, why he cannot go to his place and set up everything, is because there's a possibility that the house is not big enough. That means the platform where this data is hosted might not have enough resources, because they might have a lot of the resources based on the storage, not based on the computation. Second thing, while traveling he might forget his item. That means while he want to do processing at the source side, they might not have all the softwares or the dependencies that he need to process the data. Possible, right? Or or the third thing can be, if you take interview in his house, there's a chance that you might break the things in his house. Similarly, it may be possible that you went to his house, okay, and you start processing, and somehow you wrote a query that literally dropped the entire database. So people won't be happy, right? So access issue will be there, right? So there are so many things. Ultimate the crux is you are not allowed to use their resources for processing the data. You can create a copy and bring it to your house to do the processing, and that exactly we do. We identify the sources, then we access them, get the permission, and then we simply bring that the copy of that data into our house or our storage. That is the combination of data storage and data ingestion, right? In the data storage, when data is available, so see, if somebody is coming to your house, okay, suppose there are 100 people, 100 interviews, do you think on the first note that you simply ask them to come to the studio and this you started taking the interview? No. If they are traveling from far, what you do, even before you ask them to come, you took them to the hotel and let them stay and take rest, right? So in this hotel, all the people you are taking interviews are gonna stay, be it a person from finance, be it person from a spiritual world, be it person from politics, or be it person from XYZ. Okay, so this house become the the place where any kind of this person gonna stay. Now understand from one perspective, if you're taking interview of a politician, do you think the background of like children or kids or cartoon gonna fit the thing? Or if person is coming who is into finance, and if you started putting the pictures of celebrities, do you think it gonna complement? No, right? That means you need to have different studio theme for different persons, right? Or different themed studio based on the person. Maybe it's finance, maybe politics, maybe for spiritual. So all the person who comes, they're gonna stay. So all the person who comes, they're gonna stay at hotel. So hotel is like a common place. But when you want to take interviews, you change the studio themes, and based on that one, you bring the person to the corresponding theme studio, right? So if the person is from finance, you will bring in him to the studio with the finance theme. If the person is from politics, you're gonna bring him to the studio where the theme is politics, and ultimately the same for the celebrity or other things. So if you look from data engineer perspective, is the same. We have different type of data format. It can be MP4, MP3, text file, CSV file, Excel file, or Parquet file, or ORC file. Anything, dude. There's so many types, right? And for every type, we have some kind of a software that can process them much more efficiently compared to other. But before that, if they are coming to my house, I need to make sure that everybody can stay a place where we can easily, it can be easily accessible to all the people that are working in the organization. That means the storage is, so this particular hotel become data lake where any kind of a data can be stored. You simply commit dump here, right? We are good on this one. Data lake is done. So from here, you can take him to the particular storage which provide more than storage, that provide you the access to do more processing in a very fast and efficient manner. Suppose I got the Parquet file, or I got the CSV file and everything. I can simply take them and dump them in a database. Because in the database, using SQL, structure query language, I can process the data faster than writing a Python code. Okay, suppose I have a JSON file or XML file. I can store that in a NoSQL database, because here I can access each element much faster than creating a Python code from scratch and keep on doing it. Because if it is a software, failure chances is very less. The command that gonna follow up, the command that gonna execute, they won't have any issue, right? So this particular theme studio become your software that you use to store or process the data efficiently that you store in data lake. Perfect. So we are good with data ingestion. We are good with the data storage, data lake, right? Now, when a person is coming right from here to studio, it's not like you gonna start with interviews. Like this is the hotel or data lake, and the data you are bringing into your particular system, or even in the data lake, right? So when you receive a data, so let's take this as an example. When the person is coming from the journey, and you are taking him to the hotel, do you think you simply take him to the studio, like go and change and come? No, you talk to him, you get to know about the person, like how he's doing, how was the flight, or how was the trip, everything good, did he had a food, everything, right? What you're trying to get, you are trying to build a connection and try to get that the easily available information, so that when the interview started, you have that gist and it can be used as an icebreaker, and then you continue on this one. Similarly, if data is coming to your data lake, you need to get certain information from him, be it the name, be it the owner, where it come from, where it is dropped and everything, so that the data lake does not become data song. Let me give you the good example of this. Suppose there is a field, right? And there are a lot of buildings there, and people come here and throw their garbage everywhere. Now today what happened, you realize that the garbage you threw here, right, it has your wedding ring. And now you have to search in the pile of mountain your garbage and then the ring inside it. The problem is there is nothing like inventory or something tracking list is created where you can track it, right? So this is your data garbage or data song. Okay. So similarly, if you drop the data in our data lake and we don't maintain a record that where it came from, where it is stored, when it is last updated, who's the owner, was the data type, and the corresponding information. If it is Excel, you take the number of columns and the header information, all those things. Okay. Now what happened? This one in the first case, if suppose there is a person who always maintain a cheat sheet where he write the area name, colony name, the floor, the house number, the person who throw it, and how many garbage is thrown it, and where the garbage is thrown, like the position, their longitude and altitude, and the distance from the longitude and altitude, right? And now what happened, instead of earlier he was searching this manually, that's going to take a lot of time. He goes to this person, asks for, give the detail and get the information where is the garbage is. He simply go to that longitude and altitude and find that this is the one, and then he got the ring. So which approach was better? First one where he was like searching everywhere, or the second one where he got the information of his position from the this sheet or this particular sheet, right? That means this sheet is better. If this sheet is not there, it will become a swamp where the data is the garbage is there, right? Similarly, in the data lake, if you don't maintain something like this, it's going to convert it slowly into data swamp. So we have a, a list of item called catalog where all the information about this data is available at given point of time. And this is present in AWS Glue catalog. Okay. We are not going to this one right now, so it's catalog, right? Just remember catalog. Cataloging give you cataloging or catalog is the storage of metadata. And what is metadata? Metadata is the information about your data or data about data or information about the data. Simple. Okay, so catalog is done. Now through catalog, once data ingestion is done, okay, once data ingestion is done, data storage is done, data cataloging is done. Now with the catalog, I know what kind of a data we have, how many columns, row, whatever the data type is, I know about everything, right? As location, the format, the extension, and a bit about the inner data. Now using these three things, these two, data storage and data catalog, I am going to use data processing to process the data and convert it into something much more meaningful that I am going to deliver to the corresponding platform where it is needed for the end consumption, be it on Power BI or be it in Tableau dashboard or be it part of some Excel format. Thing, dude. Anything, everything. Right? So we got clear with who are data engineer, what are the key responsibility, and what we do in those key responsibility, right? Any questions so far? If somebody joined, let me refresh it and ask this question. No, we don't have. So we are all clear on this one. These six key steps, we don't have to worry. And this is nothing. Let's move to data discovery. Okay. So if you're listening to the entire thing that I told earlier, that data engineer are responsible for data ingestion to bring that data from different sources into our system, then the data storage where it is going to store, then data cataloging to understand what kind of a data we have, where it is, and who throw it. So so it remain a manageable platform for data storage rather than becoming data swamp, then data processing, then data delivery, and all this is happen or is currently working based on the data security and data governance that we do. But question yourself, question yourself. I'm bringing the data from the source, but who told me which source we need to use and where we need to get it, right? So this the process of identifying the data become a part of something that is performed before data ingestion is started. Remember this. Okay. This is called data discovery. What is data discovery? Data discovery means to understand if we have enough data with us or externally to complete this data engineering process or to complete our overall project. Okay. This is called data discovery. And it can be done if you follow five steps. Step number one is business value, that I will tell you what is it. Second one is identify data storage. Third thing is your data storage. Fourth one is data ingestion. Fifth one is data processing. Let me quickly check if my understanding is correct on this one. One, two, three, four, five. Data business. Yep, it's the same. Data identify, data define your storage catalog, and this one define business value, data storage cataloging, and data access, and defining data processing requirement. Okay, yep, that's the same thing. So data discovery is a phase where we need to answer these five things. Very first one is business value. Business value. So what is business value in data discovery? Business value is to align your business with you. That means to make your stakeholders or the shareholders understand that what you want to implement is going to either increase the profit or it will decrease our expenditure or losses, right? So once there's a metric that they understand that this going to improve or it will be benefit for the organization, they will agree. So business value is like to give yourself an answer that what you are doing, how it can benefit the organization. If you are able to answer it, that means you can convince your stakeholders to invest in your project. Second thing, to perform this one, you need to understand, do we have this data or not that can complete this thing? So that means we need to identify data sources where we can bring the data and process it to understand if the entire process that we want to complete as a vision is possible or not. Third thing, now from here is all about data engineer. They talk about this one, but data engineer take the references from this one. So first one is data storage. There they talk about which kind of a storage we gonna use and all this thing. And data ingestion is again how we gonna ingest the data. Do we have a permission from the person, or what kind of a permission do we need? Does it have PII data, health data, finance data? How we need to mask it? Just all talk about data identification and other thing. Fifth one is data ingestion and data processing. Oh, sorry, data processing. So now here is actually the business rule is applied. So I know, for example, let me give you an example. Suppose I want to bring the health data here, and then I want to use the health data to do something, anything. But I realize there is health data that I can identify a person. That means I can know that what kind of disease he have, and that's against the your GDRP or our compliance policies. That means at given point of time, the information that can identify a person, okay, we need to mask it. So we can simply we can replace it with a star. That's how you're gonna save yourself, right? So when you're able to answer all this, you lay a foundation for data engineering because now you know what kind of a data storage you need to use, what are the data sources you need to get access and permission. When data ingestion, you gonna plan how you're gonna bring the data from the different sources to your particular data storage. And then our last is your data processing, how you need to process the data and how you will know the data process is right or wrong, right? So this is where the data business rule came in and this business value will be there. Anything on this one? Nope. Now let's move to the third one, that is AWS service and modern architecture. This is nothing. This is the same thing that I told you, that for a data engineering you need to perform few tasks. First one is data ingestion, where you bring the data from multiple source to your centralized data storage, right? So you bring the data from multiple sources to your data storage, and from data storage you simply catalog the data catalog. That means to get the metadata about the data sets, and once that is done, you simply add the data processing process and you refine the data into something that is much more meaningful for the end user to consume, and then you simply deliver this to the data delivery to the corresponding end user. Okay, so this is something we perform as part of this one, right? Now AWS, what it stand for? AWS stand for Amazon Web Service, right? Amazon Web Services. So what Amazon Web Service does? Amazon Web Service provide you with different services on web that can enable you to perform each and every step at this module, then also able to orchestrate this one and automate the process. What is orchestration on this one, that we're gonna learn in the next chapter. But right now you need to understand that AWS provide all the tools and software to perform each and every step this one. Why it is important, why it become beautiful at this point because you now don't have to write the entire code from scratch for every single source and then execute it. For ingestion and for every scenario, the AWS provide you with a software to perform this one. For example, for data ingestion, you can use AWS Glue. You can use AWS Lambda. And if it's a streaming data, you can use MSK, manage stream for Apache Kafka. And there are many other. Okay. For data storage, you can use AWS Data Lake, that is called S3 Simple Storage Service. Or if you want to store the data in a database, they have all the database, be it MySQL or PostgreSQL, everything, but it has their own built-in database that is called Aurora. Or you can use its own built data warehouse that is Redshift. Perfect. So these are the storage you can leverage from AWS as a service. When data cataloging. There is one software that automatically run whenever there is a drop or update of the files in a S3 bucket. This is called AWS crawler, and it immediately scan the table, get the information, and update or insert into our catalog table inside AWS Glue. Okay, this is the thing. Now, data processing. Again, for data processing, that means to extract the information, process it, and get the result that end user need, okay, to consume the data. For this one, you can simply use again AWS Glue, AWS your Lambda, then your Flink or Kinesis. For delivery, simply you simply put the data to the corresponding place where you need to keep it. So end user can use its software on top of it and get the best result out of it. So this is the whole process that we understood so far. Okay, so now orchestration. Now, biggest problem with this approach is let's take an example. Suppose tomorrow you use AWS services to do each and every step. Okay, you are happy, happy, happy. And now the consumer asks you to refresh the data. So what you can do, you simply run the first query, wait till it is completed, then you run the other one, wait till it is completed, then another one, then complete it. So if it's a once a week thing or once a month thing and you have free capacity, then you can do it. It's not a big deal. But if suddenly they ask you to do it every single day, every single hour, do you think you can do it? Answer is no. There's a huge chance you might fall asleep at night and you miss out that hour where you need to run it, right? That's where we need to create an automation. That is, we write a code that automatically take over our responsibility of scheduling this thing. So what it does, the automation or the orchestrator, it take all this individual code or the services that he want to run and put them in a sequential or logical sequence, be it serial, sequential, or be it your parallel, based on the requirement and get the thing sorted. Perfect. So, any doubt on this before we move forward? Let me quickly check if somebody joined and they have something to ask. No, nobody joined. That's fine. Okay. So your orchestrator, what is does it enables you to talk between different modules and make them execute in an orderly manner. Then we have automation. Automate is simply you can schedule this on your requirement, be it hourly basis, be it on a condition basis, event basis, anything. Okay. So that's all we have on this one. So nothing much. Hmm. Then the last one that we study yesterday was data engineering and security and monitoring. So for security, data security and data monitoring. So data security has to be done very thoroughly so that there is no data breach and you can avoid a messy thing in your head. Okay. For data storage or data security, I think there are a couple of steps that you need to follow very strictly. I'm sorry, to make the things very safe. First one is data access. You need to provide the access to the particular person, to the particular group in a very orderly manner and with proper approval and the things. Okay. So you can use AWS service called IAM, Identity and Access Manager Management. Okay. Or you can use ACM, Amazon Certified Management, something like this. It is used to create that SSL or TCLM certificate. I don't know what is called certificate that help you to connect to your services through CLI or command line. Okay, that's the first security that you need to make sure you follow. The second security is always follow compliance, be it GDRP or there are other as well. And after this is done, when you are able to form and do the compliance, you need to make sure that you handle sensitive data very, very carefully. If there is some PII data, finance data, or health data, you mask it, encrypt it based on the requirement. And I think AWS provide the encryption as EM, I don't remember, but key management service, KMS, key management service. Yeah, 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 yeah. So now three is done, that access control. Then your second one is compliance, follow compliance. Third one is sensitive data. Is there anything else from apart from this? Your regulatory data regulation. Okay, yeah, two more. Data and security or data and network network security. Yep. Data and network security and data auditing. So this means is just to prevent yourself from any breach of your software or any breach of your hardware that the hacker trying to do to steal the data of your customer. That means you need to make sure your network is always secure. And finally, and the last one that's fall into this category is data monitoring. Uh, Data auditing is done. That is data monitoring. Now is like data monitoring. What is data monitoring? Data monitoring is a process of ensuring that the entire workflow is done properly. It follow four-step process where you see if the data is flowing perfectly from the workflow. Okay. Second one is he check if the the data that is moving on this platform or the pipeline reach with the state that we really want for our end user to consume. Okay. So it resources, data pipeline, resources and data access. Data access, yep, yep. So we are done with two major concept that we understood on this one, right? For data monitoring, that we're gonna check if the pipeline is working perfectly fine without any failure or anything. Second one, we check the data that move from source to target form or reach it in the format that actually we want. Third thing is to understand what is the resource utilization in the entire process. Because monitoring means itself that the resources that my job is consuming for this workflow, is it within the limits that we want? Fourth and finally is access management. And it simply means to see if the proper people are accessing the proper resources at given point of time. So once that is done, we can simply say that data engineering for AWS is for first section, that is foundation, uh, role and concept is completed. And after 5 minutes of break, we will simply go ahead and take our assessment. Okay, so let's take a break of 5 minutes. Okay, so let's get back and we will start our assessment. Let's start our quiz. So we have like 5 questions, I can say it. Let's take first one. A data engineer is working for a startup that collect data from various sources and need to build out a data pipeline on AWS. The pipeline will ingest raw data from S3 buckets, process, and transform the data and load it into a data warehouse hosted on Amazon Redshift. Which task would typically be the responsibility of data engineer? Okay, so which are the tasks we need to do it as a data engineer? Designing the schema for the target warehouse tables. Yes, it is indeed. Which tasks would typically be responsibility of data engineer? But let's look at that. Writing extraction, transforming, and loading ETL job to extract the data from the raw file, transform it, and load into the data warehouse. The problem is that I am using AWS. Is it fine or not? Let's see. Creating dashboard and no, that's data analyst work. We are not involved with any visualization so far. Defining matrices and key performing indicator that the business. This is something our CDO has to take responsibility for alongside data analyst. So he need to provide what kind of a metric they are looking for to convince the business that this process has to be completed or this they need to invest on this one, and then data analytics create the dashboard to track those KPIs. This is not something that we need to take care of. This is something the business and CDO's chief data officer need to take care of. So the first one and second one is the co-responsibility, but the major responsibility that data engineer has is to extract, transform, and load the data. Designing your you can take with the help of data architect, so we don't have to worry about this one. We are right. Data engineer's core responsibility would be building and maintaining the data pipeline to ingest data, process for the analytical use, designing the schema, creating dashboard, defining KPI related metric closely to the role of data analyst, business analyst, or data scientist. Perfect. Question number two: a data engineer is a data engineer at a startup is building out the company's data infrastructure on AWS. Okay, the company has limited engineering resources and budget. They ask the data engineer to design a data processing pipeline that minimize the cost. Which option would the engineer prioritize to meet the requirement? So we need to understand what kind of a pipeline we can do in order to ensure that the minimum data, a minimum billing the business get. Okay, so we need to cut the cost. Ultimately, that's the crux. Using on-demand Amazon Redshift cluster over reserve instances to maintain flexibility. It can be building a serverless architecture using AWS Lambda, Amazon S3, Amazon Athena instead of using provision services. It can be storing all data in Amazon S3 without optimizing and running queries directly against file. No, 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 no. There is something that we need to understand. I will tell you. Just give me a sec. Provisioning high capacity Amazon EMR cluster to process. No, no, that's not the music. Sometimes even the EMR, that is elastic mapper and reducer, but what does it does like it store the data into cluster or in a hierarchical form into multiple different computers and then process it on the partition wise and then get the data and construct it back out. But if you start doing this for every file, trust me, this is not how it's gonna work because sometimes if the file size is very less, it overhead the things. Okay, so there's certain parameters, certain level of data file size should be to maximize the usage of EMR. So that's incorrect. And storing all data nodes. So answer can be in between first and second, but but using on-demand Redshift cluster over reserve instances to maintain. From a developer perspective, data engineer perspective, our main role does involve data storage, but it is not the ultimate one. This is one of the part. If we have to make an end to end. We need to make sure the resources we are using is running on serverless. What is serverless is? Serverless means when you don't define the computer that you need or the software power you need, it is being assigned by Amazon itself internally when our systems are running, where when our AWS services are running based on the computation they provide these the power and everything, and based on that one we get charged. So serverless is far better compared to other one, because if we are not running our system we don't have to pay for any kind of infrastructure. If we are running our job based on our job implementation and the job consumption and the job execution time period and everything, it is being charged. So the answer should be second one, where we need to get the serverless architecture and get the things done. Yep. To optimize for cost with limited budget and engineering resources, a serverless architecture using Amazon S3, Athena, and Lambda could be the most efficient approach. Using on-demand cluster rather than reserve instances and storing all data in S3 without optimization might incur higher and unnecessary costs, because it totally depends on what kind of a data you are provisioning. So that's not the right provisioning high capacity. It will increase the cost. That's what I was like talking about. So this is not right thing. Now, third one, a data engineer at a financial service company has been asking to build an analytical platform on AWS that will process sensitive customer financial data. Okay, so I'm going to work into financial data. I told about there are sensitive data, and for this one, there is one AWS service called Macken. I don't remember the exact name. It is a machine learning a model that run on your data and give you the output that which particular column he think is sensitive data, PIA data. You need to mask it or encrypt it using KMS. That is your key management service by AWS that simply encrypt your data. So what it does, it find so what it says, the financial company has been asked to build an analytical platform on AWS that will process sensitive customer financial data. Compliance and information security leader have maintained the platform meet strict regulatory and security requirement. Exactly. So regulatory compliance are the GDRP or your HIPAA, and security simply that means a firewall never being breached. What should be the data engineering top priority? So it says that we need to do it, and our priority is the security, that the data that is really sensitive is never being shared. So we need to make sure that data is secure. So optimizing doesn't make sense in this scenario. You can do it, but it doesn't answer the question. Building data pipeline using the latest, it also doesn't answer. Using open source technology to reduce licensing, or it doesn't. Implementing security control like encryption, access control, and data masking to protect the sensitive data. So I told you the when we were studying, we were doing our revision, right? As a data security, we need to follow few steps, right? The first one itself is called data security, that is data access management. That says, that being said, that who can access the data should be listened and document properly, and according to that they are being provisioned the access. Second one in this data security is first one is access, second one is compliance to the data compliance, or following the compliance rule and regulatory compliance regulatory, right? GDRP or HIPAA, right? Third is sensitive data. This is the part of this one only. So sensitive data, that means PII data, financial data, or medical data, or other things that should always be masked, should not be available publicly or to anyone unauthorized. Okay. Fourth one, when everything is done, access is done, compliance is done, sensitive data is done, then you need to make sure your system, your data, and network is secure. When I say secure from unauthorized access. Fifth and the last one is your uh which one? I forget, dude. What was it? Data security and GDRP snack. Data auditing. Data auditing. That means you know how your data was flowing, from which source it flow in your AWS system, from AWS system, from which directory to directory it went, if there is any processing done, then where it has gone as the ultimate data delivery, and what was data name, everything. So when you have entire data journey information, it is called data auditing. So it helps you to understand if data is not being corrupted or it is not being manipulated in any wrong way. Okay, so that's the answer that we will submit, and we will get the right answer. Yep, we get the right answer. Let's go to question number fourth. A data engineer at a large e-commerce. So now we are not in finance, we are e-commerce, has built a various data processing pipeline on AWS that need to run on daily, weekly, and monthly schedule. So that means you have automated this thing. They want to implement an orchestration layer. Okay, so now automation is done, but they want to implement an orchestration layer to automate the scheduling and operation of this pipeline. Which tool would best fit into this one? But that's totally depend on which what you have used to create this one. AWS is that function with the AWS Lambda and AWS Glue to schedule and automate the data driven workflow. Yes, it can be. AWS Ops work to automate the operation tasks like server configuration, AWS code deploy to automate code deployment, AWS config. No. So thing is like AWS, we use the major services and we can call them through AWS Lambda. So if you're using any service, suppose we have sensitive data. Okay, let me take you here and then talk about this one. So suppose in a table or in a data source I have sensitive data. So that means whenever this data comes here, when I got a trigger, I need to run one AWS I need to run AWS KMS services, that is key management service, to run and update this file and simply mask the sensitive data, right? That's the logic. So this can be done through Lambda function. I can trigger this one KMS, and KMS will do the magic, right? So whenever the trigger happen, it will automatically call my Lambda function. Lambda function will call my EMS system, and it will simply write the encrypted, encrypted. It will encrypt the data. Why it is important? Because this Lambda function can be used as a model into an orchestration that is offered by AWS Step Function. So suppose this become one module, it can be one module where you will provide the Lambda name, everything. It will automatically trigger this one and it will execute. Second one, you have to migrate this to other place. So you will simply use AWS Glue job. And again, Lambda function, you will use it to call it here. This become orchestrated. So similarly, all the orchestration will be done through this one. So AWS Step Function is an orchestrator that use AWS Lambda to and AWS Glue. And AWS Lambda is something we use to call other services, and AWS Glue is simply ETL tool that is can be used for extraction, transform, and load. Okay, so this should be the one answer. And yes, step function along with the Lambda and AWS Glue is designed to automate the scheduling, orchestration, and monitoring of the data processing, workflow, and pipeline. Ops work, Ops works, code deploy, and AWS config are unrelated to the orchestration pipeline. This can be part of this one, but not the exact thing that we are looking from orchestration perspective. So I'll the best example to understand this one, that if somebody is sick and goes to the doctor in a hospital, right? The compounder works there, but does he contribute to that thing? No, right? He is working there in the hospital where we are going for treatment, but who's gonna treat is the doctor. Similarly, if you need to orchestrate, we need to use AWS step function. This AWS config can become a part of the workflow, everything, but it's not the orchestration that we are looking for. A large retail company wants to gain insight from customer purchase data to improve their marketing strategy. Which role would a data engineer play in the data discovery process? So what I understood this question is like there's a retail, like big retail, right? Like IKEA, okay, or $1 or anything, right? So what they want to, and they want to understand what my customer is buying at given point of time. so that I can advertise that thing more. I can provide more deals and make it a stock up, full my inventory with that particular data set, right? So I need to understand this one. So as a data engineer, what role I will play in data discovery? As I told you, data discovery is the very first phase that work where we tell the business that what value it can add. When I say value addition, it can be like it can increase the profit, decrease the losses, decrease the expenditure, or it can increase one more source or introduce one more source of income or revenue. Okay, so that's the business value. Second thing that we do in this process of data discovery is to identify the data sources that can enable me to achieve my this data vision or data values. Okay, the third one is to identify, one data identification is done, everything is done, we need to create the data storage, like the on paper, like what data storage we can use it and everything. Then data uh, ingestion and processing, data ingestion and then data processing. Okay, these two and these three. And there one more here that I forget, that is who gonna be consumer and consumer, who gonna consume this data and how they gonna consume the data. So now as a data engineer, what is that thing that I should be focusing on in this data discovery process, right? So as a data engineer, I think my core responsibility as a data engineer, you are responsible for the two major things. First one is data storage, second one is data processing. For data processing, it includes data ingestion and data actual processing that we need to implement business rules. So somewhere I will be responsible for understanding. See, ultimately this thing can be done with machine learning, right? So data scientist has to understand which data we need it, and based on that we will identify the data sources. So as a data engineer, I think I am gonna lie in the last three, obviously data storage, data ingestion, data processing. Own all customer data and be responsible for data access policies. I think data policies I can do it, but there is always an infrastructure engineer that who is responsible for this one, but we direct him who will have which access and how to make the access policy for our system. So we are responsible for them to implement this. Work with business stakeholder to understand their goal and find key metric, analyze data sources and processing requirement, recommend modern data architect. This thing is something the DO, that is Chief Data Officer, data architect, and data analyst are responsible for, alongside with data scientist, if only if he is using the model. I don't think we are responsible for this one. In just streaming customer event data from various online and offline channel into a data lake, build a machine learning. No, that's not. When it says build machine learning model, that is data scientist. Deploy a data mesh architecture and create autonomous data product that domain expert can access through a central kernel. So as a data discovery, I think this is not the one that we are looking for. So the last two, I don't think this is the one. The first two can be work with business stakeholder to understand their goal and define key metrics, analyze the data sources and processing requirement, recommend modern data architect. I think this can be own all customer data and be responsible for data access policies, approve or deny any data requests from other. No, data discovery is not this one. Data discovery is talk about everything at the initial stage. So work with this one, analyze the data process and processing and recommend the modern data architect. Yes, I can work with the architect. This is the one, I think. Yep. The best choice is that the data engineer would work with the stakeholder to understand the requirement, analyze existing data landscape, and recommend the best modern analytical solution alongside data architect. If architect is not working, then basically you are architect. You need to give the solution. But ultimately, this is just a piece of this one, not exactly this one. I will expand on this one. Owning data access policies, building machine learning model, and deploy the mesh important activity. However, they are not the prime focus of the initial data discovery. That's exactly I was talking about. This is not the prime objective. This is something you do it later as an implementation. As a data discovery, you need to understand end-to-end overall picture that you need to understand in the data discovery. In machine learning algorithm, these are something for data scientists to come. Analytical in this solution, I think data analyst has to come. For architect, it should be data architect. I will come when I have to create that entire pipeline. So as a data engineer, you are at the back and you are not responsible to talk with these guys. Data architect, data scientist, data analyst, these are the people who should be talking with the business to understand end-to-end process, right? And CTO that gonna lead this team. Data engineer is always at the back. Trust me, always at the back. He's responsible for bringing the data and processing it. But from where he need to bring and how he need to bring it, this is something we don't have to concern ourselves. So conclusion. Congratulations, you have successfully completed this one. And role and responsibility. AW analytic on AWS data engineering principles. Go to document analytical on this one. Some issue do you have encountered this one? So there is other resources, is it? Case like data engineering principles. What is that? Auditability that we understood to have that workflow end to end. Scalability, reusability, reproducibility, and flexibility, discovery. So we can learn it, but this is not something we need to do at the moment. Maybe in future, but not right now. So we are good. Contact us. Mhm. No need to contact us. So with this, we have completed our first section of data engineering on AWS. That is your foundation role and concepts. Second we gonna do is what we gonna do for storage that I talk about. For a data engineer, we are responsible. The core responsibility is data storage and data processing. So we're gonna do with the data storage. There are two data storage that we are very concerned with because we play with the structured data more than anything. So first one is data lake, where we dump everything, make it a centralized repository for data storage for universal access by our team. Second one is data warehouse, where it is useful for analytical queries, analytical processing. So we use data warehouse. So it's going to be really, really fun. Tomorrow I'm going to do and create my own account with a subscription. So you don't have to worry that you have to follow up. With this, I will take my leave. See you tomorrow. And it was fun, dude. We are able to complete these demonstrations. We have done it. We have done it. Done it. Okay.